All right, today we're looking at a piece of tech that honestly feels like it was pulled from a crashed UFO. This is the SpaceX Raptor 3. And it's not just an upgrade, it's like they tore up the rocket science rulebook and started over. So, what kind of secrets is this thing hiding? Let's dig in.
So here's the central mystery, the thing that's so interesting. When the first photos of the Raptor 3 got out, you had seasoned rocket engineers, people who live and breathe this stuff, just scratching their heads. It looked too simple, too clean. They were convinced parts had to be missing. But what if that incompleteness was actually its greatest secret?
To really understand why this engine is such a massive game changer, we need to get into its core design, its heart. We need to unlock the full flow secret. Okay, so the big idea here is something called full flow staged combustion, or FFSC for short. And you have to understand, for decades, this was like the holy grail of rocket engine design. In a typical engine, some of the propellant gets diverted and, well, wasted just to spin the pumps. But in a full flow engine, nope. Everything goes through the turbines. Not a single drop is wasted.
So, how in the world does it work? Well, think of it like a car with two absolutely massive, perfectly synchronized turbochargers. You've got one pump, powered by oxygen-rich gas, and its only job is to force-feed liquid oxygen. Then, you've got a second pump, powered by methane-rich gas, doing the same thing with liquid methane. Then, both of these superheated, high-pressure gases just slam together in the main combustion chamber, unleashing absolutely incredible power with maximum efficiency.
And when you put these designs side by side, the difference is just night and day. Conventional engines are a tangled mass of hot, high-stress plumbing because they're basically fighting their own inefficiency. But Raptor's full-flow cycle, it's cleaner, it runs cooler, and that's because it's not wasting energy. Every single component is focused on one thing and one thing only, generating thrust. Okay, so let's circle back. How does this super elegant full-flow cycle solve our original mystery? Now we can finally understand why that engine looked so incomplete to the experts. So here it is. This is the crucial point. The FSSC design is so efficient that it just eliminates the need for tons of extra plumbing, heat exchangers, and all these other complex parts. You know, the very parts that are common failure points in other engines. The genius wasn't in adding more. It was in figuring out just how much they could take away.
And this translates into massive real-world advantages. I mean, think about it. Fewer parts means fewer things can break, right? So reliability shoots way up. It also means SpaceX can build, test, and improve these engines at a pace their competitors just can't match. In this new space race, simplicity isn't just a design choice. It is a strategic weapon.
So we've solved the puzzle. But what's the big deal? Why does this one engine matter so much? Well, let's look at the staggering impact this technology is about to have on, well, everything.
269 metric tons of thrust. That is the tested power of a single Raptor 3 engine. Now, but put that into perspective for you, that's more power than 3 Boeing 747s at takeoff. And SpaceX needs 33 of these just to get the first stage of Starship off the ground. The scale is just, it's mind-boggling. And here's why that really matters. Look, immense power is one thing. But when you combine it with an engine that is this simple, this reliable, and designed from day one for radical reusability, you get the magic formula. This is what unlocks the entire vision for Starship. Without this engine, a fully reusable super heavy lift rocket would still be just a dream. You know, ultimately, this isn't just about a better rocket. It's about a fundamental shift in our future. The power and reusability of Raptor 3, they aren't just engineering achievements, they are the keys that could finally unlock the solar system for us. We're talking about lowering the cost of getting to space so dramatically that things like bases on the moon and cities on Mars move from science fiction right onto the drawing board.
So let's end with this thought. For decades, the engine was the bottleneck. The physics were there, but the machine wasn't. Well, now the machine is here. It's real, it works, and it baffled the experts with its sheer simplicity. The only question left is, where do we go first?